In this video of fluid kinematics, we are going to discuss about velocity and acceleration of fluid particle. So what is velocity? As you know from the very basics of fluid mechanics, velocity is displacement by time. Velocity is displacement by time. So again, we can say that it is the rate of change of displacement of the fluid along that direction. So whenever we mark a direction, we can call that parameter as a vector parameter also. So here, velocity, since it has a direction, it is a vector parameter. So if I take v as a resultant velocity along any direction, let capital V be the resultant velocity along any direction, and let u, v, w be the velocity components. Now if I start to represent this velocity in a three-dimensional space coordinate, like suppose if that velocity acts at a point at this point, this v can be represented as in terms of coordinates x, y and z, right? So if I want to resolve it into components, or if I want to go for further mathematical modeling, I need to split this resultant velocity into its components. So if I split this resultant velocity into components like u in the x direction, v in y direction and w in z direction. So again, all these parameters u, v, w, I can represent all these parameters u, v, w like the same what I have done over here. Suppose if the horizontal component of velocity is u, again this u can be represented in terms of x, y and z, right? As it is in the space coordinates, I can write it u with respect to some x1, y1, z1. Similarly, I can write v with respect to space coordinates x2, y2, z2. Or if I want to write about w, I can write it at x3, y3, z3. So all these velocity components again I can represent as a function of space coordinates. Also here, as v is displacement by time, similarly u is horizontal displacement in x direction by time, v is displacement in this direction, y direction by time, and w is displacement in this direction by time. So here you can see this u, v and w. All these are functions of space coordinates and function of time. So I can rewrite this as u is a function of x, y, z and t. V is a function of x, y and z and t. And w is a function of x, y, z and t. So capital V is the resultant velocity, u, v, d, w are the velocity components, and these velocity components are function of space coordinates and time. Now once you know all these components, we can calculate what is resultant velocity, how can we represent resultant velocity, and also how we can calculate the magnitude of the resultant velocity. So resultant velocity vector v can be represented as ui plus vj plus wk. Similarly, the magnitude of v is square root of u square plus v square plus omega square. Now we will move to acceleration of fluid particle. So what is acceleration? Acceleration is velocity by time, or it is the rate of change of velocity of the fluid along that direction. So here also it is rate of change of velocity of fluid along that direction. So acceleration is also a vector quantity. So if I take A as the resultant acceleration along any direction, and let ax, ay and az be the acceleration component. Similarly, what I have done over there in the velocity, I can represent the same thing, acceleration also in a graph. So let this point be the acceleration, resultant acceleration A. So if I want to analyze, if I want to produce the mathematical equations for this, first I have to split this resultant acceleration into its component ax, ay, az. So ax is the horizontal acceleration, ay is the vertical acceleration, and az is the acceleration in the direction of z. So if I take this ax, ay, az, I want to represent in this coordinates. Again, all these parameters ax, ay and az I can represent in terms of x, y and z. Similarly, as it is velocity by time, I can say acceleration is a function of time too. So all these I am representing it as a function of x, y, z and time. Now if I am going to check how the equation of ax will be, mathematical equation of ax will be, or how we can represent mathematical equation ax, let us see how we are going to represent it. So ax is horizontal acceleration. So it is velocity by time. Specifically, it is horizontal velocity by time. So what is horizontal velocity by time? Horizontal velocity is small u. So it is ax is u by t. So see it here. I am writing it as ax equal to du by dt. I think with this du by dt means it is a summation of small velocity changes with respect to time. So that's why I have written it as du by dt. We will go in detail how to expand this equation. So simply feel that ax equal to horizontal velocity by time. Now again, this u is a function of x, y, z and t. But here whenever I write the equation ax, I have just shown that this is a function of time only. Now how can I show that this is a function of x, y and z too? Let us see how we can rearrange this equation. So ax equal to du by dt, and it is a function of x, y and z and also t. Okay. So to show that this u is a function of x, I am rearranging this equation as du by dt equal to du by dx into dx by dt. So I can show that u depends upon x and still the equation is itself du by dt. പക്ഷേ എനിക്ക് അവിടെ എന്ത് ചെയ്യാൻ പറ്റും? അത് x-നെ ഡിപെൻഡ് ചെയ്യുന്നുണ്ടെന്ന് കാണിക്കാൻ പറ്റും. The horizontal velocity depends upon x and x depends upon time. So I can rearrange this equation as du by dx plus dx into dx by dt. Similarly, I can show the relation between y and z. So see here how we are rearranging that equation again. So see, du by dx into dx by dt plus du by dy into dy by dt. Now if I want to show this depends upon z also, I can add it du by dz into dz by dt. So that's how we will write all those, and along with that we have to write that it depends upon time too. So see, the final equation becomes du by dx into dx by dt plus du by dy into dy by dt plus du by dz into dz by dt plus du by dt. Okay, now see this particular equation. Keep du by dx as such. What is dx by dt? X is displacement in horizontal direction divided by t. Horizontal displacement by time is small u. Now what is y by t? That is vertical direction, right? Y by t is in vertical displacement by time. So this is small v. Similarly, what is z by t? Z by t is w. So rearrange this equation by replacing dx by dt with u, dy by dt with v and dz by dt with w. So this is the equation, final equation plus du by dt. So I can rearrange it as u into du by dx plus v into du by dy plus w into du by dz plus du by dt. So this is a final equation of ax. Similarly, we have to write about ay. So ay is acceleration or velocity change in y direction by t. So I can write it as dv by dt. Ay is dv by dt. So similarly, if I try all this way, I can write ax as dv by dt equal to dv by dx into dx by dt plus dv by dy into dy by dt plus dv by dz into dz by dt plus dv by dt, or ay equal to u into dv by dx plus v into dy by dy plus w into dy by dz plus dv by dt. And similarly, az I can write it as u into dw by dx plus v into dw by dy plus w into dw by dz plus dw by dt. So finally, I have obtained here ax, ay, az as a function of space and time. Remember, it is a function of space and time. Space and time. So always remember this equation of ax, ay and az. Once you get ax and ay and az, we can represent the total resultant acceleration as axi plus ayj plus azk, or the magnitude as root of ax square plus ay square plus az square. So next is local acceleration and convective acceleration. We know that equation of ax, ay and az as u into du by dx plus v into dy by plus w into du by dz plus du by dt. Similarly for ay and az in terms of v and w. So here when we see in detail of all these components, the first three terms are space coordinate. For the first three terms depends upon space coordinate, and the last term depends upon time. So for all these three equations, the last time is a time dependent parameter. So we can say that this last term is a local acceleration. Du by dt, dv by dt and dw by dt is local acceleration, or the local acceleration is a time dependent parameter. Similarly, the other three terms, the first three terms depends upon space only. And even though if the flow is a steady flow, still acceleration can occur in this case. So convective acceleration is a function of space and it is not a function of time, and local acceleration is a function of time. So it is not a steady flow. It changes with respect to time. So local acceleration is a function of time and it is not a steady flow. Du by dt, dv by dt and dw by dt together we call it as local acceleration, and the remaining parts of the equation of ax, ay and az, the first three terms represent the convective acceleration which does not depend upon time, which is a function of space only. So these are the definitions of local acceleration and convective acceleration.